Hey everyone, thanks for coming. Thanks Riot Games for having me. My name is Abhi Aiyer. Um, Thanks for coming. This place is really awesome. Like I've never been to a building like this, especially a building called this room is called Chobath Hall. I dream to name a room Chobath one day, or something similar. But today I'm going to talk to you guys about GraphQL, something very dear to my heart, and a library called Apollo that I've been contributing to for a couple months now. Let me tell you a little bit about me and my team. We're WorkPop. I work at a company called workpop.com. We're located on Ocean Park Boulevard, right down the street. And we are trying to revolutionize hiring for the service economy. Service economy meaning people not in this room. Right? Anyway, look at our happy family on the screen right here. My coworker Bernardo on the far left, your guys' left, got that sorority pose down. If you work at WorkPop and you're in the audience, can you raise your hand? It's like these three people. They're in the picture, so if you want to like cross-reference right now, that's it. We're hiring, by the way. That's why I'm talking about this. We're hiring software engineers right now, people who can take products end to end. If that's you, which I think there are a lot of people that could be you, talk to me after this. Let's talk and let's get something going. I don't know if there are other recruiters here, but talk to me first. All right, let's get serious. Let's get into the tech talk. I'm not going to be live coding today because you know how that is a nightmare. But I will be talking about some concepts. But let's take a trip down memory lane first. Let's reminisce a little bit. So when the web first started, not like the web, like web apps, right? It looked something like this. We were sending HTML from a server to a browser. And people were complaining because every link I clicked, every page would refresh the whole page and I would get a whole new set of data. And this just wasn't good. Like back in the Rails days before single page applications, people were just building apps like this. So I don't think anything wrong with that, but a lot of people did. So then they were like, okay, well, we should just send data to the client, and we'll have this JavaScript thing, and all the million frameworks render this data, so we can have better like application performance. So once a user loads the page and interacts with it, they're going to have a better time using the app. So that's cool. But then, I don't know if anyone here thought this way, but back then, this was like 2009, everyone was betting on mobile web. Like mobile web was the thing. So no one really thought about native. So this whole JavaScript client thing, that was the thing. That was like the way to build apps. And then we were all wrong. And native iOS and Android came into the mix. So now your API server had to talk to another client that we didn't really plan for. So now we're sending data to multiple clients. Okay, cool. Oh, great. Now the hipsters come in and they're like, all right, there's this thing called microservices. Because your monolith, this monolith here, this API server becomes a monolith. And monoliths scale until they don't, right? So people break up their resources into different microservices. And now you have browsers, you have native, you have this Cordova, PhoneGap things, just talking to these resources willy-nilly. And we needed to put some control on that. So we put this thing called an API gateway. And now we have some more bottlenecks because the guys and girls developing clients for browsers and natives apps have to interface with not only the people making microservices, but the gatekeeper here. If they need an API change, who do they have to talk to? They have to talk to like 4 people. So that's a bottleneck for people trying to build products quickly. So I'm going to talk about the not so distant future because there are companies building in the architecture I'm about to talk about today, like GitHub and Facebook. And it's called GraphQL. So this is the future of web applications. This is my opinion of what the future holds for us. The GraphQL server is the translation layer between the clients and the backend. So you can see here, there's this nice, colorful GraphQL API gateway in between it. So I haven't really explained what GraphQL is. We're going to get into that right now. Let me get into like why you should care about this. As your product scales, all your data is going to scale. The relationships between those pieces of data are going to get complex. The product manager is going to say, what if this? And you're going to be like, oh yeah, we could probably do that. Let's just add another connection here or there. So you can really express your application in a graph of data, right? You can see here we have a bunch of books with authors and co-authors and titles and all these pieces of data that are just very complex. And what GraphQL allows us to do is extract the trees of our data. So application graph is essentially a tree of data. We can extract those pieces of data for our clients. So here's a simple query. So GraphQL looks like JSON, right? This looks like JSON. I'm making a query for a book with the ISBN of a certain number. And I'm going to request that I get a title, and I'm going to get some type of authors field with names. This is a GraphQL query. It's very simple. It's not magic. Like it's not crazy. But what it does is very powerful. It returns a simple response. This looks exactly what you just like what you just asked for. This is the query. This is the response, right? Very straightforward and very easy to digest. And what did we just do? By making this query right here, getting the response, we've fulfilled what we were trying to get from our application graph, right? So that's why you should really care about this. Let's talk about REST for a second. How many people here use REST APIs? Raise your hand. Raise your hand. Everybody. If you're not using one, you're either using WebSockets or you're just not doing anything. Firebase people? Firebase? What about if you use Parse? RIP. Okay. The problem with REST APIs, like, don't get me wrong, REST APIs are used by huge companies to build crazy products at scale. Like, don't get me wrong, I'm not saying REST APIs are bad, okay? But there are problems with REST that you guys need to understand that could be solved with other methods. Who here writes REST APIs for mobile apps? Okay, some people. Who here forgot to bump a version on that REST API and all your mobile apps broke? That guy right there. If you're not raising your hand, you are a liar, okay? And that's the problem with REST APIs, it's hard to version, okay? It's really hard to version REST APIs. The minute your product changes, the minute you pivot as a startup, you're pivoting, your mobile app needs to change as well, but all the old clients, all the people who do not want to upgrade, they're not going to do it. You either have to deprecate them or they're just going to continue living. You have to worry about those people, right? They're going to be hitting the wrong API. They might be destroying your product from the inside out. Who knows, right? The more versions you add to your API, the more like /v4, v5, v13, you're going to build up a lot of technical debt because you're going to support a lot of things that your product doesn't even care about anymore. Version 3 versus version 5, like no one cares about version 3 anymore because the whole product probably changed between those versions. So that's another problem with REST APIs. The last problem I want to talk about is there is no unified structure to validating a REST call. Like how many people here have written their own validation libraries in your own product to validate REST parameters and the response? Like everybody's making up their own validation systems. So if you go from this company to the next one, they're probably having some own mechanism of building their own REST APIs. So these are problems. This is REST on the left, your left. And this is GraphQL on the right. You can see that the clients in REST, the clients have a lot of different directions they can go to get their resources from the server. But on the right for GraphQL, you're actually going through this thing called the GraphQL server. The GraphQL server is a middleman. Literally, it's the middleman between your client and the server to pretty much proxy the request from the client to the server. And it makes things a little bit more organized. So let's talk about why. What are the benefits of GraphQL? Well, one, GraphQL is fun, so that's good. This is called GraphiQL. GraphiQL is an IDE, essentially, that runs alongside a GraphQL server, and it allows you to have introspection into your data. Now, a lot of people who are testing REST APIs probably using Postman or something, and as a client developer, you're trying to see what the response is to a REST API, and then you find out that it's probably like nested like 12 layers deep, and you gotta write some map and filters and all that. But it'd be nice to know like what the data looks like before even building anything, right? And the great thing about GraphQL is it represents what GraphQL queries exist in the system, what mutations exist in the system, and it allows you to play with it in a playground before even writing a line of code in your application. So this is GraphQL, it's fun. So the problem though, and this is where I'm going to get into with Apollo, how do you translate fun in GraphQL into like having an actual app, right? It's really hard to take that on the left and turn it into an actual product. So I want to talk about how GraphQL works, and then I'm going to get into Apollo and then all the good stuff there. So how does GraphQL work? Well, there's two core parts to GraphQL. GraphQL is a query language. It's an application query language. It's not a graph database query language. It is a query language designed to query your application. And I'm talking about your application, the one that you're building for your customers today. And how we get that done is through two things: a schema and these things called resolve functions. So everything in GraphQL is typed. It's a very strict type language, which means every request is typed, every response is typed, and the validation is built in. There's no making your own validation system. It's bound by a spec. There's a GraphQL spec that has been interpreted in many languages: JavaScript, Java, you name it, Elixir, all those crazy things. And everything that you do as a GraphQL developer is bound by this type system. That means no client, mobile clients included, are going to get data that they're not expecting. There's not going to be those 2 a.m. calls where the app is crashing because someone returned null or something, and they didn't mean to, but they did. None of that will happen. That's the great thing about a schema. I say this from experience, so that's why I'm talking right here. Those calls aren't good. And the second thing is a resolve function. So this is a schema, right? There's authors, there's posts. So the two things at the top, author and post, those are your entities, right? Those are the things, those are the data that represents in the database. Author, it has a strict type, right? You can see ID is an integer, name, string. This looks familiar to you type developers. We're at js.la though, so no one really knows types here. But unless you're using Flow or TypeScript, then you can say you know types. But you probably don't really use types that much. But with GraphQL, there are types. So you can see post has a post type, right? And then you can see our queries here. So these are the queries that your GraphQL server, your client can make to a GraphQL server. It can do get author, and that's going to return an author, right? It takes an ID of an integer and it returns an author. You can get post by title, and then it says, well, the parameters are typed. Title contains it's a string. It's going to return you an array of posts. Like, you would feel so comfortable knowing that your whole application is backed by this type system. So as a front-end developer or a client developer, you're always going to get what you expect. There's no mysteries. There's no surprises. That's what it is. How does this schema translate to actual data to the client? Let's get into that. This is a thing called resolve functions. Look at this pretty diagram. Now, the client makes a request to the GraphQL server, the little red box there, in a representation of a query. These things right there, the get author, get post by title right there on the left. Now, these are just functions. In the actual code that you write for GraphQL servers are going to define what get author means. And get author, get post by title, they're just functions. Literally, they are just functions. Like, you could have get author, get post by title. All they can do is return the number 1, and that would be cool, right? As long as it, as long as it, goes with the schema. But these are just functions. Like, there's no magic here. You write your own functions, and they will resolve to whatever you want, right? So in this case, get author, it hits the author's collection or table or whatever you're using. We're pretty much database agnostic at this point. And it does what it needs to do to resolve that data. That data goes back to the client. So let's talk about Apollo. I talked to you about basics about GraphQL. Now, all these concepts, like it seems like pretty overwhelming when you get into it, but there are some libraries that we've been working on to help people start today and take advantage of this system. So before I was talking about fun in GraphQL and how does it translate into building an app. So there's an open source project called Apollo. There's Apollo server, which handles your whole GraphQL server. NPM install that, you're done. You have a GraphQL server, you start writing your schema, you start writing the resolve functions, and that's done. Over. Apollo client is the client version of how to interface with a GraphQL server. So essentially, I can tell you right now, if you're a front-end developer, you can go into this graphical interface. If you have your whole GraphQL server set up, you can start typing the queries you need to render your lists or whatever. You can literally copy and paste those into your code on the right, and things will work. So you can go in the playground, copy and paste the query, put it up in the syntax on the right. It will connect the data. It will give you the data. Everything's handled for you. And that's the magic there. So on the left, we have queries. So this is in React, if you guys know what that is. This on React, and this is a Apollo integration called React Apollo. It's based off of Redux. You can see on the left that if anyone's familiar with Redux, like we're connecting queries to components. So you can see that we're going to create a feed with data. We're going to connect. We're going to map some queries. We're going to write some queries in there, and that will map itself to the component very well. Mutations are the same way. You click a button, it'll fire off a mutation, which is written as a query as well. And this allows you to do a lot of cool things. You can pass variables from props or state or whatever to fill these GraphQL queries, and those will hit your server, and you will get the data that you need. So I'm going to talk about Apollo for a second. Apollo has a couple key mission critical things that we want to accomplish. One, community driven. So there are a lot of people who are using Apollo now from big companies, Shopify, Credit Karma, the Meteor Development Group, and then smaller teams at Airbnb. This is a community driven project. Anybody who wants to contribute, who wants to get interested in, there's first time commit issues that you guys can get involved in, and that's the point. This is a whole community driven thing. Before Apollo and this GraphQL library, there was the only one by Facebook, which is GraphQL Express or GraphQL JS, and Relay, which is another GraphQL client. And those were pretty much Facebook owned, Facebook open sourced, and pretty much only built for the Facebook problem. And now Apollo is mainly for the people who want to build the GraphQL community. It's modular and transparent, and by modular it means if you're not using Express, maybe you're using Connect or Happy or Koa for Node.js. Yeah, we have integrations for that. So we're modular in that way. You can switch in and out. For clients, we have React, Angular 2, Vue.js, Polymer. Who uses that? And many more coming. So, and then it's production tested, as I just told you. It's very incremental, and it's very compatible with what you're already doing. If you have a bunch of REST APIs today, you can convert one of them into your system, back it by GraphQL, and everything else in your system will still work, and you can constantly iterate on your process and get the whole system done in GraphQL very slowly and gradually. It's not one of those projects that makes you do hours of work on the weekend just to get it up. It's very, very adoptable very quickly. I'm going to talk about the architecture on the client. I love talking about architecture. I really think what we did for Apollo client, making it usable by any front-end framework, is really something very beautiful. The only competitor in this space is Relay from Facebook. Relay is tied to React. It's a GraphQL client for React. I just want to talk about GraphQL clients, by the way. A GraphQL client, in layman's terms, is something that can make a post request. That's really all it is. I swear to God. All you need is something that can make a post request, and that is a GraphQL client. What we did for Apollo, though, is we wanted to go a step further. Not only do we want you to be able to make a post request, We want to be able to cache your results. A nice client cache, making sure that you're never querying the same data twice, that's great for a front-end developer. You want good performance? We can do that. We want to go with the industry? We use Redux as our cache, right? Who here has used Redux or knows about Redux? A lot of front-end developers here. We use Redux as our cache because that's what the community wanted. That's what the community's using, you know? So we have this normalized cache. We understand what a query means. That funky query syntax you saw, we translate that to JSON in the cache for you guys to use in your projects. You don't have to worry about, you know, like translating this query back into the client or out. Like, it's all handled. It allows you to fetch data how you want it with the variables that you want. Allows you to do hydration from the server, so server-side rendering, which is really big. Optimistic UI, which is huge if you're, you know, in a big app that needs quick UI for the user. And because we're using Redux, every state change is very, very predictable. It's very easily watched. And yeah, so that's the architecture here. On the right, the client, the UI components, they make a request to the Apollo client. We minimize that query. So some ugly query, we take it, we store it in the Redux store. We hit the GraphQL server. The GraphQL server will send us this ugly blob. Oh my God, it's ugly. Pretty much REST, right? It's like super ugly. But we handled it for you. We normalized that, what you wanted. We store the results of that query in Redux. So if you ever query it again, we'll pull it from the Redux store so you don't have to touch the server again and waste resources. We compose results through the integrations. So every UI layer integration that you want, we'll compose it for that UI integration in its format that you need, and your users will see the data that they requested in their components. So today's features of Apollo Client, every mutation you make, every button click is tracked in the Redux store. It's logged, so you can pretty much do time travel and all that crazy cool stuff. You can do reactivity via polling. The Apollo Client by itself will do polling intervals for you. So if you want to not constantly refetch and watch that data, it'll poll for you. But you can also refetch data whenever you want. It's reactive. There are WebSocket integrations where you can actually have some real-time data using GraphQL. There's React Native support. There's a React Native talk after mine. We are fully compliant with React Native. People are using that today. Query batching, which is really good. If you have like 5 UI components all querying different resources, in an interval, we will batch those queries together. Your client will make 1 request, not 5, and you will get all the data, which is one of the coolest features that I worked on. Optimistic UI is great, just because you don't want to wait for that latency. Pagination is always pagination. You know, in general, pagination just sucks. Like in general, like it just sucks to get pagination right. Things could change. We handle pagination pretty well, so take a look at that. And then fragment composition. Fragment composition is just like how we build objects in JavaScript today. You want to be able to reuse parts of different schemas. So we have that ability of composing schemas together so you can share different resources and compose them together. So it's cool. This is the owner, not the owner, the creator of Redux. His name's Dan Abramoff, and he tweeted that Apollo also works with Redux dev tools. So if you're a Redux user and you're already using the ecosystem and its tools, that we integrate with that. And why wouldn't we? Right? Why wouldn't we? Also, you don't have to use React to take advantage of these dev tools. You can have any of our view layer integrations. So cool. So these are the integrations: React, Angular 2, Vue, Polymer. We have native iOS. We have React Native, and Android is coming soon. You just need more Android developers in the community that are interested in GraphQL, and that'll be out very soon. All right, so that was the whole front-end spiel. So if you're a front-end developer, I hope you love that, because there's a lot of goodies for you to play with, and maybe convince like all the people on your team that to use it. But for the back-end point of view, I want to talk about these things. GraphQL allows you not to worry about these UI-specific round trips. Like for mobile, for mobile especially, mobile developers, they have different views that are different from your web app. They may request different resources for those views. And you can see in these URLs right here, there's a mobile preview, an Android feed, and you as a backend developer probably have to support that. Mobile developers are divas too, so they want things a very particular way. And you have to support them as a backend developer. So, and you end up probably with this structure here. You got posts for the web app, and you have a post for maybe your Windows app, if you're crazy. And then you have a mobile preview, and then an Android. It's just too much, man. In GraphQL, here's an example. In GraphQL, on the left, the original schema was film, right? And the director was a string. It was, Steven Spielberg. And then somehow, those mobile developers, man, they wanted the directed. What are they directed? All the films, and they wanted to know if this director was also an actor for some to get featured on the App Store, whatever reason they want. And before, you'd probably be making new endpoints here. But in GraphQL, you just keep the old director key there, and you create a new key called directed by, and that has a new type, and all your old versions of the mobile apps will still know what director is. We haven't destroyed it. It still resolves to a string. But now we have our new API for our new people to consume, and that is this directed by key. So this versioning story is a lot better now. And you have this new dev workflow, right? It starts with the UI and API developers. They come together. They say, this is the schema that we can support on the client. This is the schema that the API developer will give you on the client. Once that's good, the UI developer can go away and start mocking that data out. Because you know the schema, you can just mock the data very well. You know what the response is going to be. And the API developer, they can go back in the dungeon and build their APIs, And once it's all built out, they come together, they test it, and they ship it. That's it. So thanks. That's all it is.
So on the server side, let's say we have an existing Rails app or Django app that declares all its models. Are there any bindings or tools that allow you to kind of skip the resolver part and just introspect what you already have?
No. And there's a good reason for that. The main reason is introspecting that doesn't help the client. And on the back end, GraphQL was not made for back-end developers to make their lives easier. It was made for front-end developers and client developers to make their lives easier. So as a back-end developer, your life does not change. Sorry. But the iteration process is a lot better. You get to be more collaborative with your counterparts on the front end, and that is what the value is. And less bugs that way, and less complaining and stuff like that. So.
We got one more over here.
Hey, do you know that to describe the
Which one? This one? The what?
The movie.
Oh, the movie, like in the beginning?
No, it was like
in the middle? Oh, this thing.
Yeah.
All right, cool.
They have the director property.
Yes.
Does anyone make that person dot name? Does that make sense? So you don't have to duplicate the questions.
I couldn't hear you. Sorry.
So for the director property,
Yes.
is there any way to make that person dot name? So you could specify a person object and it'll dynamically retrieve the name.
No, so at that point, it's just a scalar value, right?
Okay, yeah.
So that's usually what you want when you're just doing single properties like that. You could define another type, which is just person.name as its own type that you can share between director and directed by. You could do that, but I don't know if you want to, but you could totally do that.
All right, guys, let's give it up for Abhi. React Native gives the React Native CLI has a new library command that is a really bad command. It doesn't do yet anything great. But with the exception of it gives you a nice little structure, and we're just going to totally change that structure around. So this is how I started this. I started creating a new library. I'm going to call it Sound Machine. And then I'm going to